As an introduction to the triangle, again, I'm going to pull up some of the questions or comments people made, okay? Because that's going to drive us into what the problem with the triangle really is, the ultimate problem, the underlying problem, okay? Okay, so let's start with the first one, which is this. Okay, fellow says, essentially he copied this from the Wikipedia, verbatim. An experiment is a procedure carried out to support, refute, or validate a hypothesis. Okay, so what is this fellow talking about? Well, he's talking about this. He's talking about something which the question is whether it has anything to do with science. Because support, refute, and validate, all those things have to do with opinion, with belief. An experiment has to do with evidence, with creating evidence or generating evidence, or eventually presenting this evidence. Why do we create evidence? What does a prosecutor do with evidence? Well, his job is to persuade the jury. That's what experiments are used for. Experiments are used for evidence, and evidence is just used to persuade, nothing more, to convince yourself of something. You could be the juror. Okay? You could be the guy who's trying to convince himself, or either convince yourself or verify some theory that you have or whatever. Experiment has to do only with belief. Only with belief. There is no other purpose for an experiment. Therefore, an experiment is not in itself an objective explanation of a mechanism. Okay? The only purpose of an experiment is to target opinion, belief. That means that it's going to be used to persuade, convince, convert, and recruit. And those are the definitions of religion. Religion is opinion, belief, persuading, convincing, converting, and recruiting. That's what religion is about. Okay? So experiments, evidence has nothing to do at all with science. Okay? And so here are the questions. Okay? Is science about running an experiment? Is science about observing? Is it about making prediction, repeating the experiment to verify what? Just to convince yourself? Collecting data? Describing with an equation? Is that what science is about? Because this is what people think science is. This is what they've been drilled to exhaustion to believe, that science is about running an experiment, observing, verifying something. What is all that? That all has to do with belief. Belief is religion. So, maybe the experiment convinced you of something. The guy on the other side of the planet, he doesn't believe in the same thing that you did. So who's right? And then you do the experiment in front of him and say, but here's the experiment. The guy continues to believe something else. So what have you proved? To whom? To yourself? So you proved to a group of people, and these people now have the same religion. And the rest believe in something else. They have a different religion. So who did you prove to? So this is the issue. The issue is that science is not about proof. Science is not about experiments. Science is not about evidence. Let me prove it to you. Okay? Let me present evidence so that I prove that science has nothing to do with experiments. Okay? Let me do an experiment. Very expensive experiment. Okay? Don't do this. Very dangerous. Don't do this without an expert next to you, a relativist, especially. Okay? We have a pencil. Okay? We let go of it. It falls to my table. Okay? If the table wasn't there, it would fall to the floor. Let's do it repeatable, because all experiments must be repeatable. Okay? A repeatable experiment. We're going to do it twice now. Okay? There it goes. Fell to the floor this time. Okay? Always falls down. You don't believe me? Do it at home. Just grab a pencil, pen, whatever, spoon, let go of it, and you'll find out it falls to the floor. What did we prove with the experiment? What was the purpose of the experiment? What do you know about gravity? What do you know about what caused gravity to happen? Okay? That's the question here. And here, you can push your hand, wave your hand above it. You can wave your hand below it, and there's nothing. There are no strings. There are no particles hitting it from above. There are no strings pulling it from below that you can detect or see. So the question is, what has an experiment told you about the objects, the things that are coming in contact with the skin of the pencil? That's the question. What has come in contact with the skin of the pencil to make it fall down? Was there something hitting it from above? Was it something pulling it from below? What can you feel or see, okay, below and above? What will an experiment tell you about gravity, for example? And here's another experiment, okay? I always show this. Two little magnets there, okay? And, you put them next to each other, and you have, what you have is attraction. And in fact, you can see here, I'm holding it just barely and it's already pulling it. It's already, I'm trying to hold it apart and it already, you know, the green one goes to the red one, no matter what I do. And so the question is, what is in between these two magnets? Can you see anything here, or are they outside? Can you see or touch anything outside? So the question is, what came in physical contact with these two magnets that forced them to come together? That's the question. That's where we start. And so for this, you got to go to the word object. You got to find out what a thing is. Okay? And this is what we find. Okay? One fellow defines an object as that which you can see or touch. And you will see this also in the dictionary. The dictionary says an object is that which you can touch or see or touch. Okay? That's the notion people have. It turns out that they have the same notion for the word exist. In other words, for them, the word exist and the word object are synonyms. They say an object is that which you can see or touch, and that exists is what you can see or touch. So it's a result of this that they have equated touch with exist with object. They say these two things are synonyms. Okay? And that's where the problem starts, because if you think that an object is that which you can see or touch, and you cannot see or touch what's between these two magnets or outside the two magnets, if you cannot see or touch what's above or below the pencil, does that mean there's no object there? And that's what people have concluded. They've concluded that there is no object because they cannot see or touch it. There's no object that exists in there because they can't see or touch it. And they equate object with existence. And so they say there's nothing there. What they don't realize is that when they do that, what they're doing is filling that space with spirits. They're saying gravity is done with magic. It's done with spirits, with angels, black magic, whatever. Magnetism, since you can't see or touch the object, there is no object there. And so what they do is fill the space with spirits. That's what they're doing. Anyone who does not put an object there and say there's no object that came in contact with these objects is essentially putting a spirit in there, is doing black magic. He's explaining with black magic. And here we have a fellow, and he defines it in a different way, defines the word object in a different way. He got this out of the Wikipedia again. An object is an identifiable collection of matter. Okay, so what are we saying? Is that that's a bunch of apples is an object? A collection of matter? Is that what it is? A collection of anything for that matter? A collection of trash is an object? Is that what these people are saying? And says, which may be constrained by an identifiable boundary. May or may not be. Like, we don't care. It doesn't matter if it's got a shape, if it's got a boundary. If it's a collection of matter, a collection of apples, we'll call that an object. That's what this fellow is saying. That he just copied it from the Wikipedia without analyzing what he copied. And you can see where he goes with this. He goes to visible, intangible. The boundary is usually the visible or tangible surface of the object. Okay, so he thinks that it's got to do with tangibility and with visibility. He thinks that this is a question of running an experiment, touching and seeing, to prove the existence of the object, which are synonyms. The existence and object are synonyms. And that's why he arrives at this conclusion. He says, if light is a massless particle, I thought a particle was, or an object was a collection of matter, and matter is that which has mass according to the Wikipedia. Now he's saying that this one has no mass, and two high energy beams interact. Then you have a mechanism which occurred what? Without an object. He says that you can do physics without an object. And there you have an example. You have all these lights crossing, all these beams of light crossing each other. And he's saying that light, you're staring at nothing. That's nothing. He's saying there's nothing there. And if you look up in Quora, okay, here's what you'll find for light, okay. Someone asks the question, says, if light is a wave, what is waving? Okay, good question. These were the different kinds of answers that they got, and there's more of them there, but you can look them up. Look up that question in Quora. And one guy says it's the electromagnetic field. Another guy says, no, it's the electromagnetic wave. Like if a wave is a field and a field is a wave, like they're synonyms, right? The other guy says a wave is propagating what? Energy. The other fellow says the answer is space. It's space that's waving. Or nothing, in other words. And another good fellow says, oh, string theory says that it's a string that's vibrating. And another fellow finally says there is no medium for light. So these are the answers you get after, what, thousands of years of being familiarized with light, and especially the last 100 years. Since quantum mechanics was invented, these are the answers these people give you. And they're all, these people say, oh, I'm an expert, I'm a physicist. physicists, and these are the answers they give you. They give you all whatever, they just put words in there. And we still don't know what the answer is. What is waving when we talk about light? We need to identify what is waving, what physical object. These people are saying, no, we're going to do it without objects. We're going to do gravity without objects. Nothing came in contact with a pen. It just fell by magic. Nothing pushing it, nothing pulling it, because, we can't see or touch it, and an object is that which you can see or touch. And when you have two magnets come together, there's nothing between them or outside of them pushing them together, because, again, we can't see or touch them, whatever's there. So the magnets just came together by magic, just because they wanted to. We have no mechanism. And these people do so-called physics with magic, with spirits. They're introducing spirits, they don't even know it. They're not even aware of that. Okay? They introduce words, concepts such as field and wave and so on, and then you say, well, what's a field, what's a wave? It's the undulation of nothing. There's nothing there. So these are the answers you get. Okay, so this takes me to my conclusion for this little segment, okay, the introduction, and this is it. The principle of secret agents. Okay? No experiment can elucidate what an invisible, intangible entity is or looks like. The only way to determine what secret agents Mother Nature uses to do gravity, light, magnetism, etc., is through thought experiments. Visualization. You have to think, you have to pull back and visualize what Mother Nature could be doing all these things with, gravity, light, and so on. And that's the only way you're going to figure it out, and that's the only way you're going to understand how Mother Nature does her magic. But if you say there's no object there because we proved it, because we can't see or touch anything in that region, then you're filling that same region with spirits and black magic and just walking away and saying, well, I'm not going to deal with that question anymore because I can't see or touch it. And what's an experiment going to show you? Well, if you can't touch it or see it, an experiment's not going to help you very much. That's the conclusion. Okay, and so what does this have to do with the triangle? Well, it turns out that the triangle is a figure, and a geometric figure. Okay, and a figure is the synonym of the word object, of the word thing. That's what a figure is, because the definition of the word object, figure, thing is that which has shape. So it doesn't matter which word you use, which synonym you use, that which has shape. Okay, and so here we have a triangle. Okay, or several of them, and the question is, what is a triangle? And you say, well, all those are triangles. Well, no, we have to go by the definition or the description that people made out there, and the one we're still using today are the ones created by Euclid. Okay, he came up with all these so-called triangles, okay, or the definition, and obviously, he got that from other Greeks as well, right? And so all these are not the same. So let me show you what the differences are. The first one is just an outline, just a bunch of dots. Is that what it is? Just nothing in the center. It's not a plane, it's just a line that went around. Is that what a triangle is? Or is the triangle the one on the side, which is the one, the dotted line, but with a filled center, or the filled, whatever enclosed within the boundary? And there's a difference between that and the solid line on the bottom. The one on the bottom, the two on the bottom, actually, have solid lines. These other guys are dotted lines. So which one is it? Is it a dotted line? Is it a segmented line? Or are we talking about a solid line, continuous line? Which of the two is the triangle made of? Well, for this, we got to look at the word line, because that's the word that's used to define the triangle. Okay, let me get this one out. And here you see it. This is Euclid's triangle. This is how he defined it. Okay, so that we find out that he did it in terms of lines. He says, a boundary is that which is an extremity of anything, of something, whatever. A figure is that which is contained by any boundary or boundaries. And again, he's going to consider what a triangle is a figure. So rectilinear figures, right, are those which are contained by straight lines. Okay, trilateral figures being those contained by three, talking about a triangle. Of trilateral figures, an equilateral triangle is that which has three sides, and he goes into isosceles, scalene, and so on. Okay, fine. So he's got different types of triangles. And then he says, further triangle, well, he just goes over that again. He just talks about right-angled and acute-angled triangles. So he just mentions different types of triangles, but what are they contained by? Lines. So we got to get down to the bottom of this and find out what a line is, okay? Because that's what he's going to use to encapsulate his triangle, okay? So here it is. Well, that's, let me get Euclid's line first, okay? Here's Euclid's line, okay? And you can see the definition. He says, a line is breadthless length, okay? And what is the line? The ends of lines are points, and a straight line is what? Is a line which lies evenly with the points on itself. What is a line made of? Points. Okay, and by the way, the modern people have the same notions. Line, a set of points, okay? Often described in terms of 2 points. Okay? So what is a point? Well, they tell you, it's a location. That's what a point is. So a line is a bunch of locations. Every time they use the word line, they're talking about a bunch of locations. There is no such notion as a continuous line, a solid line, a line made of a single piece in all of modern or ancient geometry. The line is made of points. What is a point? It's a location. That makes a line an itinerary. So when we're talking about a triangle, a circle, or a square, we're always talking about itineraries. Why itineraries? Because the mathematicians, what they do is they measure. They unroll their measuring tape, and they're going to measure something. And so what you're essentially doing is looking at the location of the front side of your measuring tape that you're unrolling. That's conceptually what's happening with geometry. So they have no use for an object such as a circle or a square or a triangle. They can't do anything with that. They can't put the word triangle in an equation and the word square in another. What they can put is a measurement of a side or of an angle or whatever. But they cannot put a plate like this. Here's the circle, okay? They can't put circle in an equation. What are they going to do with this? They have no use for this, for the genuine circle that belongs to geometry, okay, to the plane. They have no use for that. Okay, so here's the line. Okay, this is it. It's an itinerary. It's a bunch of locations of the turtle. This is what it is. But even if you don't agree with me on that and you say, well, maybe it's not just, maybe it's just a bunch of locations, static locations without any motion. Okay, so this is what you're saying. You're saying it's just a bunch of apples. You're just saying that each one of those dots represents a location, for example, of an apple. So it's either the one on the left or the one on the right. That's what a line is. And that's what they're going to encapsulate the triangle with. Okay? And again, it's because they're talking about motion and they're not talking really about locations and motion. And they're not talking at all about a geometric figure. Okay? Okay, so that's why the other day I covered this. Here's your famous circle. Okay, circle is an itinerary, circular itinerary. Okay, here's the, I can find it here. Here's the square. Okay, I showed the other day. Okay. That's what they have. That's what a square is. Square is just a bunch of locations of an apple that's going around, some kind of perimeter or whatever. Okay, and so this takes us to our famous triangle. Okay. Guess what a triangle is? Here it is. You'll see it for the first time. That's what a triangle is. It's a bunch of locations. It's a little dot, which is actually a representation of a location. It's a location of different locations. That's what it is. They represent it with a dot so that you can see something and think that you're looking at a figure. Okay? And yes, you can go in there and say, well, what if we freeze those? Okay, so that's what you get. You get a triangle. That's your triangle. And is that what a triangle is? A bunch of dots? Just a perimeter? Nothing in the center, because that's what a circle is said to be, okay? Just a bunch of lines, and lines are made of points. So what are these people talking about, you know? And this is the issue. The issue is that there are no geometric figures in geometry. They're all itineraries, they're all locations. And if they're locations, first, it doesn't belong in geometry to begin with, because geometry is about shapes. First and foremost, you have to have a shape before you can do geometry, just like you have to have an object before you can do physics. And they don't have objects. And now you can see where I'm coming from. Yeah, because they have all these concepts out there. They have black holes. What is that? A singularity, zero-dimensional singularity. And they think that's a geometric object. Then they talk about space-time. What is space-time? Well, it's how they explain gravity. What is gravity? It's a geometric theory. Okay, why? Because they're saying it's the shape of space-time. So what is space-time? Is space-time a physical object? Is a geometric figure? No, space-time is a concept. It's motion, space, time. They're talking about time. They're talking about motion. That's what they're talking about. They call that a geometric figure, and they talk about the geometric theory of gravity, and that's what general relativity supposedly is. That's how geometry entered the world of physical interpretations, which they call mathematical physics. Okay? So this is where the problem is. The problem is that all these so-called figures are not figures. What they are is itineraries. And because they started with itineraries, they ended up with itineraries. Okay? And so what we have today is only explanations based on itineraries, and we're missing the objects. We're missing the things, the figures. Okay? We don't have a mathematical physics theory based on objects. And we don't have, as a result, we don't have actually any physical interpretations. All the so-called physical interpretations are concepts, are motion in motion, locations in motion, locations in locations, motions in motions. What is a wave? Wave is something already in motion. They talk about the movement of a wave, the oscillating of a wave. And when you look at the wave, there are a bunch of vectors. And it's all like this, all over mathematical physics. You won't find a physical object. And that's why these people eventually conclude that, light is not mediated by an object. Magnetism is not mediated by an object. Gravity is not mediated by an object, right? Because they can't see or touch it. And they're supposed to visualize it, but they don't worry about that because mathematicians don't worry about visualizations. They just want equations. They want to only describe how the pencil fell, or with what strength a magnet attracts another, or how fast it went, or whatever. They're not interested in the objects themselves. That's why we don't have physical, true, genuine physical interpretations in physics today.